Okay, brilliant. Thank you. Okay, so this month's EcoSTEM challenge is, so now we were looking at maths around us. Now we're going we're going out of this world. We're going to the solar system. So this month's challenge is exploring the solar system, which is in the curriculum. So first of all, just a little bit of a reminder of some of the general guidelines. You know, what we want with these EcoSTEM clubs is for the students to really have fun and enjoy and discover. You know, we want them to try things out, to discover things for themselves. So it's very much that they're at the heart of the clubs and you're working along with them. And although we know that some of our EcoSTEMs are in schools and in school classrooms, the good thing is, you know, you don't have homework and exams and tests and things. So there's more freedom than a normal school, a normal class, a normal science class. You can spend more time discussing things with the students and letting them try things out, and less pressure. And, you know, we really want them to feel free to try things out, even to get things wrong. So do encourage their participation and their effort, even if sometimes, you know, you might think it's not quite the right answer, but if they're trying to work things out and enjoying and discussing, then that's great. Quite often in these challenges, the students are going to be working in groups. So again, just a reminder that group work can be really valuable, but you do need to make sure that all the group members are allowed to express themselves and to participate. And sometimes it's good to mix things up. You know, sometimes when you tell people to get into groups, they all go into the same groups as last time. And sometimes it's good to deliberately mix the groups up and get so that the students actually work with each other, with different people. Okay, so this month's challenge is about the solar system. And the main idea is to help them understand more about the solar system, and especially the distances, the scale of distances. And this is something I'm actually personally very interested in, because it's something that we don't often really understand. And once you get an idea of the distances, it really changes your whole perspective about the solar system, space, and the whole universe. And there's a nice little mixture of different things. They're going to do some drawing, so they use their creativity. Then they're going to create the scale model. And then there is a little bit of maths in the extension challenge. Okay, so sorry, let me just move this. So the basic idea is, by the end of the challenge, they'll be able to explain what the solar system is and what it comprises of. They'll be able to name all the planets in the solar system in the correct order. And they'll have a better appreciation of the scale of the solar system. And what I mean by that really is the distances of the planets from the sun. Okay. Now, as you know, we normally start with some discussion questions. Remember, this is just to get them talking, to find out what it is they know, what they don't know, what they're interested in. We've got some example questions. Of course, you can use your own. I'm sure you'll come up with wonderful questions of your own, but things like, you know, what is the solar system? What are the components? What's it made of? What does it consist of, I should say? How many planets are there, and can they name them in order from the sun? And maybe some things about the characteristics of the planets, like, do they know which one is the smallest planet, the biggest, the hottest, which one has the most moons, things like that. And do they know about how the planets move around the sun? So just general information, general background about the solar system. So that's actually what I'm going to do first. I'll go through a little bit of that, and again, I'd like some interaction. So apologies, I sort of stole some slides from a different presentation I had, so that's why all the colors have changed now. So now it's interaction time. So tell me, please, what are the components of the solar system? What things are in the solar system? So you can either put them in the chat, but in that case somebody might have to tell me what's in the chat because I can't really see it, or you could unmute and just shout out some of the things that are in the solar system.
We have the stars.
Okay, stars.
We have the heavenly bodies.
Okay, so and when you say heavenly bodies, what do you mean?
We have the planet, the other heavenly bodies. We have the comet.
Okay,
We
comets,
have.
great.
Oh, I'm forgetting my science. So
It's okay. Maybe can anyone else add? So we've heard planets, we've heard comets. That's great.
We also have the sun. It's part
Sounds
of the
good.
component of the solar system.
Brilliant.
So
Yes.
it consists
we
of
also
the
have
sun,
the moon.
The moon. Good. Yes.
heavenly bodies like the meteorites and then the asteroids.
Okay. Great. Asteroids. Yes.
Yes.
Anything else? Is anything else anybody would like to add? It's sounding good so far.
Please, question.
Yeah, sure.
Is the challenge based on the new curriculum or the old curriculum?
That's an interesting question.
Because
yes, yeah, please ask.
With the old, the new curriculum now, the solar system, the content of it is different because they are to know about the inner planets, the outer planet, and some other few things. But in the old curriculum, those things are not there. So are we to base it on the new curriculum or the old curriculum?
I suppose then really it's the new curriculum. I mean, the thing about the distances, which is the main part of this challenge, is not specifically in the curriculum. But I suppose I was looking at the new curriculum when I put the you know, the like the curriculum link. But it's still general information about the solar system. Yeah.
Okay. Thank you.
But that's a good question. Thank you. Okay, so let's just summarize. Yes, in the solar system we have one star. So it's very common. A lot of people do say stars because when we look up at night we see all the stars. So sometimes we think, oh, they're all in the solar system, but actually there's only one star in the solar system. That's the sun, and the other stars are much further away outside the solar system. We have the planets, and we have 8 planets. We also have dwarf planets, and remember Pluto is the most well-known dwarf planets, but there are others. At the moment there are 5 known, and of course the Earth, we have our moon, but lots of the other planets also have moons, and in fact there are over 200 moons in our solar system. We have asteroids, as somebody mentioned, and comets. Asteroids is probably millions, comets there are thousands. And yes, so these are the components: the sun, the planets, the dwarf planets, moons, asteroids, and comets. Okay. So, and this is specifically part of the challenge. So, and I'm sure everyone can do this, but let's go through. So, can we name the planets in the correct order from the sun? So, which is the first planet nearest to the sun?
Mercury.
Okay, great. Mercury. Next.
Venus.
Venus rather.
It's Venus.
Okay,
Venus.
Mercury.
Venus, Mars.
Earth, Mars, Jupiter, Saturn, and Uranus, and Neptune.
Hang on. So after Venus, it's so far I've got Mercury, Venus, and then what comes next?
Earth.
Okay, good. And then
the Mars,
Jupiter,
and then
Jupiter,
then
Saturn,
and then Uranus or Uranus, however you want to say it, and then finally
Neptune.
Brilliant. Good. No problem. Yes. And often we say that the first 4, we call them the inner planets or the rocky planets. And then the last 4 we call the outer planets or the giant planets. Often these days they call Jupiter and Saturn the gas giants and Uranus and Neptune the ice giants. Okay, and here's a picture of, if you like, the regions of the solar system. So as I said, the sun on the left, and then the inner planets, and then the asteroid belt. So that's where most of the asteroids are, not all of them, but most of them. And then the outer planets, and then then there's another area which maybe not everyone might know, called the Kuiper belt. And that's actually where Pluto is, and some of the other dwarf planets and a lot of the comets. Now, this picture is sort of very common, and as you can see, it looks like the planets are almost equally spaced, but the distances are not to scale, and that's actually what the main part of the challenge will show. They're going to create a scale model to show that the distances are actually not like this at all. Okay, now, so a few quick planet facts and figures, because you might want to discuss this with the students. So we'll do it with questions. So which one is the smallest planet? Any answers for which one is the smallest planet? Does anybody know this one?
Yes.
Okay,
Mercury
so
is the smallest.
okay, great. Yes, so Mercury is the smallest planet. Good. And which one is the biggest planet?
Jupiter.
Yes,
Brilliant.
Jupiter.
Okay, great. Jupiter is the biggest. Which one is the hottest planet? I'm talking surface temperature.
Mercury.
Does everyone
Mercury.
agree that
Yes,
Mercury is
Mercury.
the hottest planet? This is an interesting one. Now, Mercury is the closest to the sun. So logically, you would think it is the hottest planet. That would make perfect sense. But interestingly, it's not the hottest planet. It's Venus, which is the hottest. And the reason for this is that Venus is covered in a very thick blanket of clouds. And those clouds, they're actually full of greenhouse gases, and they keep the heat in. And so because of that, the surface temperature of Venus is actually hotter than Mercury. So it's actually a lesson for us about global warming, because Venus's atmosphere is full of greenhouse gases, and that's why it's so hot. So yeah, so Venus is actually the hottest planet. Now, here's also a tricky one. I think, can people keep on mute? There's some sort of slightly odd noise happening. Which planet has the most moons? Any guesses for this one? This is tricky. Which planet has the most moons? Be brave, somebody. Be brave. We can just have a guess.
I'm going to guess Venus. I know nothing about this.
Okay, thank you for guessing, Kat. Anyone else want to guess? Okay, someone saying Jupiter. Any other guesses? So we've got Venus, we've got Jupiter. Just feel free with a guess.
I'm not good at guessing, so
Saturn.
Jupiter.
Also, okay, so we've got Venus, Jupiter, Saturn. So it's actually Saturn. And the reason it's a tricky question is that new moons are being discovered all the time. So right now, Saturn has 146 moons. And a few months ago, it was only known to have about 80 or 90. So this is as at May this year, new moons were discovered. And so now Saturn actually is the planet with the most moons, but it may be overtaken in future. So that's why I said it's a bit of a tricky one. Things like this, you might have to look up carefully on the internet before you talk to your students. Okay. Okay. So again, I'll just briefly, so here's the position of the asteroid belt between Mars and Jupiter. Most of the asteroids are there, but some are, in other places as well. So it's not that that's the only place they are. And again, just quickly, because we have other things to do, asteroids are just small rocky objects or metallic objects left over from the formation of the solar system, all different sizes and shapes. Most of them are sort of funny shapes. Most of them are not spherical. And some of them even have their own moons, interestingly. And then that you said before, from that picture, beyond Neptune is an area called the Kuiper Belt, which has thousands of small icy bodies, including the comets and some of the dwarf planets. And comets are basically, they're a bit like asteroids, but they've got more ice in them, and they're further out, and they orbit in a very oval path, like an elliptical path. And when they come close to the sun, the ices evaporate, and that's what gives them the long tail that you can see in this picture. So it's not often that you can see them with the naked eye, but if you can, they're very beautiful, like this one from 1997. Okay, so again, here's just the summary again of the regions of the solar system. Okay, and again, just a bit about the sizes of the planets. So that little tiny dot, the third dot from the left there, is the size of the Earth compared to the sun. So the sun is enormous compared to the planets. All the objects in the solar system orbit the sun, and they're kept in orbit by the sun's gravity because it's got such an enormous mass. And in fact, the sun has over 99% of the mass of the entire solar system. So just like less than 1% is all the other things, all the planets and dwarf planets and moons and all those other things. So the sun is really enormous. And there's just another little picture of the sun and Earth. Okay. And who can tell me what's special about our planet? What's special about planet Earth?
Us.
Planet Earth.
What edgy spots?
Okay. Can
The
I
only
come in?
planet with the perfect
Yeah.
conditions of life for eddy spots.
Hi, Miss Cat.
Hi, Francis.
Okay, planet Earth is the planet that supports life
Great.
due to presence of oxygen. And
Yes.
okay, let me end it there. Somebody should also continue.
That's great. That's right. Yes, it's the only place, as far as we know, that supports life. Because yeah, it's got the oxygen that the life that we need needs oxygen and water as well. So all the things you hear about aliens is at the moment is all fiction. We haven't found any evidence of any
Hello?
life anywhere else. Yes, hello. Hello. Did somebody want? Yeah. Did someone want to say something?
Yeah. Please, I want to ask about the Mars. Is it support the life? Is the
Sorry, I
planet
couldn't hear.
the Mars? Is it also support the life? Mars. The planet,
On Mars?
yeah.
No, as far as we know, there's no life on Mars. But the reason people talk a lot about life on Mars is that the scientists can tell when they study Mars that in the past, it used to be much warmer and they believe it had running water on the surface. Right now it's dry and there's no water on the surface. But because it had water in the past, a lot of scientists think it could have had life in the past. So there's investigations going on looking at the chemicals and things to see if they can find evidence of past life. But there's nothing, as far as we know, there's nothing there living at the moment.
Oh, okay.
Yeah, but people are always very interested in Mars, yes. But anyway, let's get on. We have to get on to our challenge. So the first activity, the preliminary activity, is a nice one, creative. Get the students to draw a picture of the solar system. So they can do it in as much detail as they want, use their creativity. But what we want to see is the sun and the planets labeled and in the correct order. But apart from that, they can add anything else they want. If they want to add asteroids, they can. If they want to add comets, they can. It's totally up to them. So that's the first simple preliminary activity, draw a picture of the solar system. Now, the main challenge, as I said, it's about distances. So you're going to construct a scale model of the distances using a T-roll. So what I'm going to do is, I've just realized, okay, so I'll go through the basic instructions, then I'll stop sharing my screen and show you the T-roll. Okay, so because basically what you're going to do is get the students into groups. You're going to give each one the T-roll, and they're going to draw on the T-roll the planets, and they're going to put the planets into the correct position by using a particular scale. And we'll give them the scale because the maths is not the important part. So it's actually going to be one sheet of toilet paper is, can you believe it, 100 million kilometers. Okay. And then there's a list of distances you'll see in a moment, and you're going to work out using the scale how many sheets of toilet paper represents the distance of each planet from the sun. So in other words, it might be, oh, okay, here's my T-roll. It's 2 sheets of toilet paper to get to Mercury, and then 3 sheets to get to Venus. and then 5 sheets to get to Earth. I'm not saying that's what it is, but it could be something like that. Okay, and we'll give you the formula as well, because I said that the main challenge is not to do with the maths, it's to do with seeing the scale. Okay, so you'll be given this table with the list of the distances. So you see the third column there. So using the formula at the bottom, you're going to be able to fill out that third column, and you can just use a calculator. It's not that they have to do any complicated maths or do it in their head or long division or anything. You can just use a calculator. Okay, so the idea is, as I was just saying, you sort of count how many sheets until you get to the next planet, and then they draw the planet on the T-roll, so that by the end you'll have a long piece of T-roll with the positions of the planets marked on it. Okay. Okay. So hold on. So let me just stop a moment. Okay. So here's my T. Oh, you know what? Well, let me get rid of my blurry background, because I know sometimes you can't. Okay. So you'll start off. Whoop, where's my? Okay, like this. So where the first, join is between the T-rolls, that's where you're going to put the sun. And it's easy, I will tell you, it's easier to draw on the T-roll using a pen rather than a pencil. Okay. And then using the calculations, then you work out, maybe, as I said, maybe it's 1 T-roll square to get to Mercury. So then you'll draw Mercury after 1 square. Okay, or it might be less than 1, or it might be more than 1. So you'll keep unraveling and drawing the planets along the T-roll. Okay. Does the basic idea make sense? I will go over it in a bit more detail, but does the basic idea make sense? So you're going to end up with 1 long sheet of T-roll with all the planets marked along the T-roll, and then you'll see the real scale of distances. Does the basic idea make sense?
Yes.
Okay.
Hi.
Okay. Yes.
Please,
Okay.
can you take that over again?
Okay. So you know what I'll do? I'm going to share the screen again, and we'll do the first couple of calculations, and then I'll draw it on the T-roll so you can see. So hold on a minute. Okay. So this is the list you'll get of the planets and the distance of each planet from the sun, and then you're going to work out how many sheets of toilet paper, sheets of T-roll, represent each distance by using this calculation. Okay, so I hope, well, I can do it on my phone, but maybe if someone's just got their phone there or a calculator. So let's say the first one, you're going to say the number of sheets that represents Mercury's distance is going to be the distance of Mercury, which is 57 million, divided by 100 million. So does somebody want to do that? The 57 million, oops, my ear thing is falling out, divided by 100 million. Has anyone got a calculator there? Otherwise, I can do it on my phone.
0.57.
Okay, great, 0.57. So, okay, let's do the next one. Because it's only because on my next bit of paper I've I've put too many of the answers. No, let me just go to the next one. Okay. Oh, hang on, what's happened? Sorry. Okay. Yes. So you're going to end up with something like this. So for Mercury, you do 57 million divided by 100 million, and you get 0.57. And you keep doing it all the way down. So for Venus, 108 million divided by 100 million, and you get 1.08. And then Earth, 150 million divided by 100 million, and so on. So the students can copy this down and you'll do the calculation and you'll fill in this third column. Now, remember, the third column represents the number of sheets of toilet paper that represents the distance of that planet. So because the first one is 0.57, in other words, that it's less than 1 sheet of tea roll. So it's about half. So it's saying from the position of the sun, it's only about half a sheet of tea roll before you get to Mercury. Okay, I'm going to draw this and show you in a minute. And then to Venus, it's about 1 sheet. So 1.08, obviously that's almost 1. So Venus is about 1 sheet of tea roll from the sun. Earth is about 1.5. Now, and let me just say, obviously, you can round this up. Don't feel that you have to calculate exactly where 0.57 of a tea roll is. You know, it's about half. That's fine. 1.08 is about 1. You know, so Earth is about 1.5. Mars is about 2.28. So I'm actually going to draw this. Sorry, I should have had one ready. So Mercury there, and then this is Venus 1.5. Then I'm going to do my okay. So again, I'm going to stop sharing a minute. Okay. So here's my sun. And then here's Mercury, which is about half a square of tea roll from the sun. And then Venus is here. It's about 1 square of tea roll from the sun. And then the Earth is about 1.5. See, I've just marked them with an M and a V and an E. Earth is about 1.5. And Mars is about 2.25. Oh, I've done it a bit wrong there, but it's about 2.25. Okay. So basically that's what you're doing. And so the students are going to draw the planets on the tea roll and label underneath. Okay. And then you basically just keep going and keep going and keep going. Does that make a bit more sense?
Yes.
Yes.
Okay, great. Let me go back to...
This is mind blowing, though.
I like it when people say things like that. Okay, now sometimes oh, there's a bit of an echo there, I think. I don't want to give too much away, but as you can see, you might be surprised that the inner planets, you know, half a toilet roll, half a toilet paper, so half a sheet, 1 sheet, 1.5 sheet, 2.5 sheets, they're all quite close. When I get to Jupiter, suddenly we've gone to 8 sheets. Now, as you can imagine, when you look at the numbers, because I don't want to give it away too much, it's actually very surprising how many sheets of toilet paper you have to go to get to Saturn and Uranus and Neptune. So that's the big sort of discovery, is that what you'll end up with is a long sheet of tea roll, and the inner planets are relatively close, or very close really, to the sun compared to the outer planets. But of course, please don't tell the students this before you start. Please let them discover this for themselves. But that is actually what you'll end up with. Surprisingly, you'll see that all the inner planets are really quite close to the sun, and then the outer planets are an enormous distance away, much further than you would have thought. And that's like the big eye opener. Okay. Oh, hold on. Oh, what's happened to my... Okay. So now doing that model shouldn't be too difficult, because we've given you the maths. As I said, we don't want the students to get all to find the maths difficult. So we've given you the formula. But what we'd then like the students to do is to look at that model and to kind of discuss some of these points. So, maybe look at the model and ask them, what are they surprised? Are they surprised at anything that they see? And we actually would like a video of the students talking about this. So there's not, there are, I don't want to say there are right answers. We just want them to make some logical conclusions from what they see on the model. So they can just say generally what they found surprising about the model. What do you think they've learned about what the temperature might be like on each planet? Because now you can see how far away they are from the sun. And maybe they could think about, do you think there could be liquid water on other planets? Now, the reason that's an interesting question is that on Earth, all life needs water. So as far as we know, life needs water. So when scientists are looking elsewhere in the universe and wondering if there might be aliens or life elsewhere, they actually look for water first. So that's why it's an interesting question. So looking at how far away the planets are from the sun, do they think liquid water could exist on other planets, and why or why not? So some might say yes, some might say no, but they should justify it. And if you were going to send a spacecraft to a planet from Earth, what can you see about how easy or difficult that would be? And then maybe they can say which planet in the solar system they'd like to visit. So ideally, we'd like a video of this, or they can write it in their own words. So it's looking at the model and trying to make some logical conclusions from what they've learned. Okay, so that's the main challenge. Anything on the main challenge? Let me just go back. Are we okay so far? Okay, now the extension challenge, we have given you a little bit of maths. Because the thing is, when you look at that list of planet distances, distance, it can say something like 58 million kilometers, but that doesn't mean anything, does it? None of us know what 58 million kilometers looks like. But if you sat down and actually worked out, can we mute, please? But if you actually sat down and worked out how long it would take you to cover that 58 million kilometers, then you really get more of an idea of the actual distance. So that's why we've got a little bit of maths here. So they can try to work out how long it would take to go from, let's say, from Earth to Mars. So you have to work out the Earth to Mars distance, and then imagine you're going on a bicycle, maybe 10 kilometers an hour. Work out that time. Then what if you were in a bus at 50 kilometers an hour? See what difference that would make. Then if you were in a plane, and a normal plane goes about 900 kilometers an hour, see how long it would take. And then we can take what's sort of a typical speed of a spacecraft is about 50,000 kilometers an hour, and see how long that would take. So it's just to try to bring home the idea of these huge distances. Okay, good. Okay, so things you'll need, obviously, is fairly basic pens and paper and art materials, and just the T-roll really, and as I said, a calculator. And I said for writing on the T-roll, it's much easier to use a pen than a pencil. Okay. Oh, now here's our little did you know, which actually you've seen already, that we feel that our planet Earth is enormous, or it is enormous to us, but it's tiny compared to the sun. Again, it's good to think about distances and sizes. So the diameter of the sun is actually over 100 times bigger than the diameter of the Earth. You could fit the Earth across the sun 109 times. And if you thought of like volume, if the sun was hollow, like a sphere, you could fit 1 million Earths inside. So these are some things quite good for just kind of blowing your mind. Okay, so submission. For the preliminary activity, we just want to see some photos of the drawings. Now, of course, you don't have to send every single drawing from every single student, maybe just a nice variety. And remember, they must have the sun and the planets labeled and the planets in the correct order to get the full marks. And then for the main challenge, we want to see the scale model, either photos or a video, so we can see that, yes, it looks like it's been done correctly. And then ideally, as I said, videos of the students talking about those discussion points, talking about, I was surprised to see something, something, something. If it's difficult to do a video, you could get the students to write a report. Please, we always want to see the students' work so we know it's done by them. And then for the extension challenge, just send us some photos of their calculations. Okay, now very quickly, because I know our time is getting on, here's like a bonus. Well, this isn't part of the challenge, but because you're learning about the solar system, the planets, can we see any of the solar system planets with the naked eye? Here's a question. So can we see any of the solar system planets with the naked eye?
Yes.
What do you think?
The sun.
Okay. Well, remember the sun is really, it's a star, but you're right, we can see that one.
We can see the Venus.
Okay, good.
What's the difference between a sun and a star and a planet? I'm really new to this.
Okay. Oh, that's a very good question. Okay. So a star is something which generates energy. It generates its own light. So remember, the sun is giving us all that heat and light, and it's because it's generating a whole load of energy in its core and giving it out. But planets don't do that. Because if they did, we wouldn't be able to live on the surface of planet Earth. So when we see the planets, they're illuminated by the light from the sun. So basically, a star is a luminous object, and a planet is a non-luminous object.
Thank you.
Okay.
Professor.
So yes.
And we can also say that the star is stationary, where the planet revolve around it.
Now that's a very interesting question, or an interesting point. I know that's something that we often say, and it's said in a lot of textbooks. If you're talking about the solar system, then you can think of the sun as stationary in the middle and the planets going around. Yes. But if you're talking about the universe, the sun is not stationary. The sun is part of our galaxy, and it's actually orbiting the center of the galaxy. So one of the very interesting things about the universe is almost nothing is stationary. Everything is moving.
Okay, thank you very much.
But I know that's a very, a lot of people say that, yes, that the sun is stationary. So, and as I said, if you're just thinking of the solar system, then you can kind of think of the sun as stationary in the middle, but in reality it's moving. But anyway, let's go back to our planet. So yes, so which ones can we see? So somebody said Venus. Can we see any of the others, do you think? Does anyone think we can see any others?
Yes.
Venus is the brightest. Okay, someone said yes. Yes. So which other ones can we see with the naked eye?
Venus.
Okay, apart from Venus.
Jupiter?
Okay, yes, we can see Jupiter. Any others? Oh, people's time. So let me just give you them, because I don't want to take up too much of your time. So yes, actually you can see Mercury, Venus, Mars, Saturn and Jupiter. All of those can be seen with the naked eye. Now, you can't always see all of them every night. It all depends on the time of year as they're orbiting the sun, but it is possible to see those. Venus is the easiest to spot because it's very, very bright. Saturn and Jupiter are often also very bright. Mars can be bright. Mercury is tricky to spot because it's always very low down near the horizon. So this evening, after you finish this call, you can go outside, look to the east. I hope it's clear for you. I haven't normally in Accra, it's been a bit rubbish recently. And Saturn is rising in the east. In fact, it rises immediately after sunset. So by now, it's probably a bit higher than it looks in this picture. So it just looks like a bright dot, like a star. You can't see the rings with the naked eye, but it is there. A bit later, maybe after 10 o'clock, you can see Jupiter, and tonight the moon will be close to Jupiter. So do look out if you're still up at that time. The moon will be close to Jupiter. And then if you're an early riser, Venus is now in the morning before dawn. Okay. Yeah. So if you're an early riser, you might be able to see 3 planets. You'll be able to see Venus in the east before dawn, and then Saturn at that time will be going down in the west, and Jupiter and the moon will be maybe sort of more or less overhead. So do take a look, and do encourage your students to go out. You know, you're learning about the solar system. It's great to actually see it. And during the month, I'll try and send reminders for people to go out and have a look, because it's always a nice thing to do. Okay, so that's actually everything I wanted to cover for our September Solar System Challenge. I will send this PowerPoint, and I'll add some extra notes and also some little probably links to videos. There's some wonderful videos where you can learn more about the solar system, and I'll also actually try and do some photos of the scale model to make sure it makes sense to everybody. But any questions on what?
Yes, madam.
How can you differentiate between the planet and the stars if you are watching them with your naked eyes?
Yes, very good question. It is difficult. So that's why you have to kind of know more or less where it's going to be. One small difference, which you can sometimes tell, is that you know how we say twinkle, twinkle, little star, and the stars, they do tend to kind of twinkle. The reason they twinkle is it's to do with the atmosphere and turbulence in the atmosphere. But when you look at a planet, normally they do not twinkle. It's like a steady light. So when you see a dot, it does look like a star, but it's like a steadier light, and you know you're looking in the right place. Then that's when it's. There are actually lots of free apps, for mobile apps. I have to say, I tend to use an app on my desktop. So, but things called Star Walk and oh, I don't know. There's lots of free ones, and those ones, there's some you hold them up to the sky, and it will tell you what you're looking at. So that's another way you can help. I tend to use something called Stellarium, which you download. It's free, but you download it. But I think there is a web version. I think there's a Stellarium web version as well. But yes, you do have to kind of more or less know where they're going to be. Yeah. Any other questions?
Yes, ma'am. I'm just going back to Miss Kat's questions.
Okay.
If I heard you right, you said the sun is also like a star, right? The
yes,
sun is
our sun is a star. Yes, yes.
So comparing the sun and other stars, which one of them is the hottest?
Oh, that's a great question. Well, I mean, the sun is actually quite an average star. I mean, of course, it's special to us because it's what gives us all our light and heat and everything. But compared to all the other stars, it's fairly average. So some stars are hotter than the sun and some stars are cooler. So, yeah. But yeah, I mean, but all stars are made of more or less the same thing. So they tend to be in a kind of a particular range. But yeah, some stars are very big and bright and hot, and some stars are a bit cooler and yeah, not so big.
Okay. Question.
Okay.
And,
any other questions? Oh, I can see
yes,
there's
please.
more people than I saw at the beginning. So thank you for the additional people who joined.
Yeah, please. I want to get the explanation you gave again. You said Venus is the hottest planet.
Yes.
I think some of us as teachers in the classroom would have to revisit this topic and reteach our students, because I've learned a lot.
Okay.
And yeah, oh no, let me be sincere with what I taught them, because the course outline and the textbooks we are using, the closest to the sun is the hottest. So if you can give me the explanation to why Venus is the hottest once again, please.
Okay, yes, fine. It's a great question. I mean, yeah, if it says that in the textbook, then yeah, that's actually wrong. But I always say it's totally logical. It's totally logical to think Mercury would be the hottest because it's closest to the sun. It makes absolutely perfect sense. So the reason Venus is hotter is that it has a very thick atmosphere. And the atmosphere is made of mainly greenhouse gases, carbon dioxide and sulfuric acid and all sorts of horrible things. But they're greenhouse gases that trap the heat. So when the sun heats up Venus, that heat cannot escape. It's all trapped. And that's why the surface temperature of Venus is hotter than the surface temperature of Mercury.
Okay. Wow.
Yeah, very interesting. Okay. Any other questions on the challenge? Or as you may or may not know, astronomy is my thing. So I'll be here till 10 o'clock. If you have lots of questions on astronomy, I'm happy to answer anything. But also, of course, anything specific on the challenge, or please feel free. But if you have to go, because we have gone past our time, so if you need to go, feel free to go. Thank you very much for coming. But any other questions, I'm still here if anyone wants to ask.
Please, will you be available if maybe I wanted to have probably a discussion session with my students, either on Zoom or online? Will you be available?
Yeah, that could probably be arranged. Yeah.
Okay.
I mean,
I will
yes,
do that.
you can send me a message and we can see how we can arrange that. Yeah.
I will do that. Thank you so much.
Okay.
I want to ask, why is that you feel hotter on the earth than when you move a bit ahead above the air?
Sorry, can you say that again? I didn't quite catch it.
What do you feel when you're on your earth? You feel hotter than when you lift yourself or you move above the earth more? You feel cooler.
So you're saying as we go up, why do we feel cooler?
Yeah.
Actually, that's a very interesting question and a very complicated question. And it's something I have to say I don't know that much about. But I know the atmosphere, our atmosphere has all different layers, And actually, sometimes the temperature decreases and sometimes it increases in these different layers. And it's all to do with the, what's the composition of that part of the atmosphere and how that reacts with the sun. So it's actually an interesting question. It's not like just a logical, it gets hotter because you're closer to the sun or cooler because you're getting higher. It's like quite a complicated thing, all to do with our atmosphere. That's not a very good answer.
Can we use about reflection in this sense? Reflection that when the sun rays hit the earth, it's also bounce back. That's where it's more concentrated on the earth than when you move up. Can we use that one?
I have to be honest, I'm not sure. I wouldn't like to say, yeah, I'm not entirely sure. That's a very good question. And it is a question I'm not sure. I will look it up.
Okay.
And see if I can find out.
Okay.
Yeah, I can't give you a good answer, and I don't want to say something that's not right. So I'm going to write it down. Great question. Thank you. Anything else? Because I do think we should start to wrap up.
Yeah, Ma. Hello.
Yes. Hello. Yes. Please go ahead.
Just another clarity here. So as far as we know, if the surface of the Venus is something that is so thickened, which they trap, let's say it trap more greenhouse effect, right? Which makes it more hotter, right? So now comparing the greenhouse, is it also the possibility that the Earth itself is as a result of the ozone layer that prevents the indirect or the direct heat from the sun?
Say that again.
What I'm saying is, for the explanation that you kept, the surface, the thickness of the surface of the Venus is what makes it to trap more greenhouse effect. That makes it more heat or hot, right?
No, hold on. No, not quite. It's what I'm saying is Venus has a very thick atmosphere. So not the surface. Above the surface, its atmosphere is very thick, very dense, and the atmosphere is full of greenhouse gases. So there's so much greenhouse gas concentration in the atmosphere that's why it traps the heat. So just like on Earth, we're worried about greenhouse gases that are making global warming. In Venus, it's like it's a runaway greenhouse effect. There's so much greenhouse gases that's what's let the temperature go so high. It traps all the heat, and that's why it's so high. So it's the atmosphere, the thickness of the atmosphere, and the fact that the atmosphere is made of greenhouse gases like carbon dioxide.
That's okay. So that means the consistent release of carbon dioxide or monoxide is what actually depletes the ozone layer. That sometimes in normal areas we feel like some kind of hot heat, and I mean, is that the case?
My understanding is that they're two different things. The ozone layer is different to the greenhouse gases. I mean, things like the carbon dioxide are greenhouse gases which trap the heat and are causing global warming. The ozone layer is something a bit different. And there was a big worry, remember a few years ago, that there were certain chemicals that were causing that hole in the ozone layer, which meant that more ultraviolet radiation could get in and actually would cause more skin cancer. Yes. Ozone, I can't remember, is ozone a greenhouse gas? I'm not sure. Yeah. So my understanding is they're kind of two slightly different things.
Okay.
Yeah.
Great.
Please, anybody can put me right. I'm not a professor, despite what Kat says. Okay. I think we should round up because time is getting on. I don't want to keep you. And remember, you have to go out and look for the planets. Obviously, we're all on the WhatsApp group, so feel free to send me any questions or if you need any clarification. But I think, thank you very much for coming. It's wonderful to see so many of you. I think it's really important to see you all at this session. So thank you for coming. I know sometimes it's difficult to make time. And please just keep in touch with us. Ernest, you're still there? Yes, remember Ernest is here. So Gertrude, I know she had problems with her internet. You all know Gertrude as your coordinator. Now we also have Ernest as our peer mentor. So the three of us are the team. Please feel free to get in contact with any of us with any issues or any questions.
Okay. Thank you.
Great.
Hello, please, Madam Sarah.
Yes.
On your demonstration using the T-roll.
Yes.
Yeah, I didn't get that because of my network. Can you please make a short video and send us on the platform?
Yes, I will do it.
Using the T-roll to do the
Okay, yeah, Joseph, your audio, sorry, I'm not sure, can't remember if that was Joseph, the audio was going, but yes, I will do either photos or videos to explain the T-roll thing. Yes, I will do that. Okay.
Yeah, it's because of my network. I was saying
no
that
problem.
Your demonstration. Hello.
Yes, that's I heard you. Yeah, so I will do. Yes, I will.
Can you hear me now?
Well, it's coming and going, but I heard that you were asking if I could do a video to show the demonstration with the T-roll. So yes, I will do that.
Okay. Bye.
And okay.
Hello. Please, I came in late because I'm traveling. I'm in a bus traveling to. Hello.
Good evening, Madam Janet.
Hello. Good evening.
Yes, I can hear you.
Okay, I came in late.
No problem.
I've asked a question, but I don't know whether you've seen it. I want to know the difference between the stars, satellites, and the planets.
Okay, great question. Yeah. Okay, so so a star is basically a luminous body. So a star is something that generates energy and gives out light and heat. So our sun is a star, and we know when we go outside it's really hot. So it's generating a whole load of heat and energy. And even all the stars that seem so tiny that you see in the night sky, they're basically the same thing. Just that they're much further away. Sorry, my cat is attacking me. So a star is a luminous object that's giving out a lot of light and energy. So it's a luminous object, but a planet does not do that. A planet is not a luminous object. And really, someone asked this before, and I actually didn't say this part, but a planet is something which orbits a star. Yes. I mean, of course, it's not the only thing that orbits a star. Sorry, I'm talking and thinking at the same time. So, so a planet orbits a star, and also a planet is a non-luminous object. It's not generating light and heat. Now, the term satellite, I've seen it used in different places because generally speaking, the term satellite just means a small object which is orbiting a larger object. So it can be a moon which orbits a planet. That is a satellite. You know, our moon is a natural satellite. You could really also say that a planet is a satellite because a planet orbits a star. I know we don't normally call it that, but really that word satellite, that's what it means. And then, of course, we have artificial satellites, which we have orbiting the Earth. So I think it's normally used to mean something that orbits a planet, like a moon, or maybe like smaller objects like asteroids and things. But the general term just is a small object orbiting a larger one.
Okay.
Is that okay, Madam Janet?
Yes, please. I'm okay. Okay. The reason I was asking this question is at times look at the stars, and some people will say this is a satellite. This is the star. So that is why I don't know. At times when we see the object blinking, those what they say is a satellite. But with the explanation now, I can also say something about it. Thank you.
Okay, yeah, because we can see sometimes if you live in a place where the sky is very nice and dark, there's not too much light pollution, not too many lights from other buildings, you can sometimes see there's thousands of satellites orbiting the Earth for telecommunications, and some of them are for astronomy, some of them are telescopes, some of them are all sorts of different things. Some of them you can see a tiny little dot moving across the sky. So it is possible to see a satellite, but that they move quite fast. It's not like a star. You'll see it at a particular position, and maybe an hour later you'll notice that it's moved across the sky. But a satellite moves almost like a plane, but it's much smaller thing. Some of them you can see in a very, very dark sky. So, but the normal just the twinkling is normally just a star. They just twinkle.
Okay.
Thank you very much. I do appreciate.
No problem. No problem. Okay, good. Okay, I think we need to go. If you don't mind, Ernest, can I just ask a quick question? Because some people have joined since the beginning. I don't know if you have a note of everybody who's joined.
Like what I would say is that, because the technology is sometimes very frustrating, because personally I have tried about 10 times to let's say enter the room